Here is a real scenario that played out on a team I advised last year. A senior developer, 8 years of experience, respected by the whole team, approved a pull request in under 3 minutes. The code looked clean, it was well formatted, had comments, passed CI, it shipped to production. 6 hours later, a race condition under high concurrency caused a payment service to double charge customers. When we did the postmortem, the senior dev admitted something uncomfortable. He no longer instinctively traced control flow when reviewing AI-generated code. He trusted the shape of the output. And that trust cost the company real money. Now here is the stat that should scare you. 82% of the developers in the US are now actively using AI coding tools. And at the same time, internal code review defect catch rates at multiple mid to large orgs have dropped measurably over the past 18 months. More AI adoption. Worse review outcomes. That is not a coincidence. And by the end of this lecture, I am going to show you exactly why this is happening and what to do before it happens to you. Let me frame the paradox precisely, because this is the core insight of everything we are going to cover. The more fluently you use AI coding tools, the harder it becomes to catch what AI gets wrong. Think about that for a second. It sounds backwards. You would expect that experienced AI users get better at spotting AI mistakes. But that is not what happens in practice. When I look at developer skill profiles from teams that adopted AI tools heavily 18 to 24 months ago, I see a consistent pattern. Before heavy AI use, developers show strong signal on code comprehension speed, edge case intuition, and debugging from first principles. After 18 months of heavy AI use, output volume is way up, sometimes 3 to 5 times more code shipped per sprint. But when I run targeted assessments, give them a subtle algorithm with no AI assistance, the same developers perform significantly worse than they did before. The gap is not about knowledge, they still know the concepts. The gap is about judgment atrophy. The mental muscle for reading unfamiliar code, tracing execution paths, and feeling when something is off, that muscle weakens when you stop using it. And here is the uncomfortable truth about developer identity. Most of us now define our competence by what we can ship with AI, not by what we understand without it. That definition is going to cost you, unless you build the right habits now. So what are you actually going to walk away with after this lecture? I want to be direct with you, because you have seen enough content that promises transformation and delivers motivation. This is not that. Here is the concrete promise. By the end of this lecture, you will have 5 daily practice routines, each taking under 20 minutes, that keep your core engineering instincts sharp while you continue using AI tools at full speed. Not instead of AI. Alongside AI. These routines are grounded in Robert Bjork's research on desirable difficulty and Anders Ericsson's deliberate practice framework, applied specifically to the context of AI-assisted development. You will also get a team-level evaluation framework, a way for engineering leads and CTOs to measure whether their developers are actually growing in the AI era or just producing more output, because those are 2 very different things. And most orgs right now are measuring the wrong one. I have watched 3 distinct waves of tool dependency patterns in my 25 years. IDE autocomplete over-reliance in the late 90s, Stack Overflow copy culture in the 2010s, and now AI vibe coding. The engineers who came out stronger from each wave had one thing in common. I will tell you exactly what that is. Let me show you the full map of where we are going, because I want you to understand why the order matters. We start here in Chapter 1 with the problem statement and the stakes. In Chapter 2, we go deep into the cognitive science, why your brain literally stops building new neural pathways when AI removes the struggle. This is not opinion. There is hard neuroscience behind it, and it will change how you think about every AI interaction you have. Chapter 3 is the historical pattern analysis. 25 years of watching developers plateau when they handed control to tools. You are going to recognize yourself in these patterns. Chapter 4 is where we get practical. The 5 deliberate practice routines, with specific implementation details you can start tomorrow. Chapter 5 is for team leaders, how to redesign your engineering culture and growth metrics for the AI era. And Chapter 6 ties it together into a personal development system. Everything in this lecture is evidence-based. Claim, I will tell you where it comes from, cognitive science research, real incident data, or pattern observations across teams I have directly worked with. This is not my opinion about AI. This is 25 years of watching what separates developers who keep growing from those who quietly stop. And the AI era has made that gap wider and faster than anything I have seen before. Let us get into it. Here's something counterintuitive that took me years to fully accept. Difficulty is not the enemy of learning. It is the mechanism of learning. Robert Bjork at UCLA coined the term desirable difficulty in the 1990s, and his research is devastatingly relevant to what AI is doing to developer brains right now. The core finding: tasks that feel harder in the moment, retrieving information without prompt, solving problems without hints, writing code without autocomplete, produce dramatically stronger long-term skill in coding than tasks that feel smooth and easy. Your brain literally builds deeper neural pathways when it has to struggle. The friction is the training. Now think about what GitHub Copilot, Cursor, and ChatGPT do. They systematically eliminate every single point of productive friction in your coding workflow. Every moment where your brain would have had to reach, to stretch, to reconstruct, AI fills it instantly. It feels like productivity. It feels like flow. But neurologically, it is the equivalent of having someone else at the gym while you watch. The muscle does not grow. And here is the part most developers are not ready to hear. The more fluent the AI output feels, the more dangerous it is for your actual skill development. We will see exactly why in the next scene. Let me make this concrete with a comparison every developer should internalize. Retrieval practice, the act of actively reconstruct knowledge from memory without looking it up, is one of the most robustly validated learning techniques in cognitive science. When you force yourself to recall how to implement a binary search or reconstruct a Redux middleware chain from scratch, your brain strengthens the pathways to that knowledge. You are not just using the skill, you are reinforcing the wiring. Now contrast it with what happens when you tab complete an AI suggestion. You are not retrieving anything. You are pattern matching and accepting. The cognitive work is minimal. And here is where the fluency illusion kicks in, a term you need to burn into your memory. After 3 months of AI-assisted coding, developers report feeling more confident in their skills, not less. Why? Because the code runs, tests pass, PRs get merged, the feedback signal from the environment says you are good at this. But the feedback is a lie. It is measuring the AI's competence, not yours. I have seen this exact pattern destroy mid-level developers' ability to pass technical interviews. Skills they used daily for a year had silently evaporated because they were never actually retrieving them. So ask yourself right now, when did you last write a non-trivial function entirely from memory without AI and get it right? Your honest answer tells you a lot about where you actually stand. There is a researcher named Manu Kapoor at ETH Zurich, whose work on productive failure is something I wish had existed when I started mentoring developers in the early 2000s. Here is what Kapoor found in a series of rigorous studies. Students who were given a hard problem first, with no instruction, forced to struggle, make mistakes, and generate flawed solutions, significantly outperformed students who received direct instruction first, not slightly, significantly. The struggle before the solution builds what researchers call a richer problem schema. Your brain, having grappled the problem space, having encountered its dead ends, is primed to absorb and deeply connect the correct solution when it finally arrives. The failure was not wasted, it was load-bearing. Now look at what every AI coding tool does. You start to type, and before you have even fully formulated in your mind, the AI offers a complete solution. The struggle is skipped entirely. The schema never forms. You get the answer without ever building the mental architecture that makes the answer meaningful and transferable to the next problem. I have watched this happen to brilliant junior developers. They can ship features faster than any junior dev I have seen in 25 years, but put them in front of a novel problem with no AI, and they freeze. Not because they negligence, but because their brain never built the problem-solving scaffolding that only struggle can construct. In the next section, we will connect this to Anders Ericsson's work and see exactly what kind of practice actually builds elite-level skill. Anders Ericsson spent his career studying what actually separates world-class experts from merely experienced practitioners. His finding, which he documented in Peak and dozens of peer-reviewed studies, is that raw hours of practice are nearly meaningless without a very specific structure he called deliberate practice. And I want to be precise here, because most people misread Ericsson's work. Deliberate practice is not just practicing hard, it has 3 non-negotiable components. First, you must operate at the edge of your current ability, not comfortably inside it. Second, you must receive immediate, accurate feedback on your performance. Third, you must actively focus on correcting specific weaknesses, not reinforcing existing strengths. Now apply this framework to what AI-assisted development actually looks like day to day. Component 1, Edge of Ability. AI keeps you well inside your comfort zone by handling everything hard. Component 2, Immediate Accurate Feedback. AI gives you feedback on whether the code runs, not on whether you understand it or could reproduce it. Component 3, Correcting Weaknesses. AI routes around your weaknesses rather than exposing them. All 3 conditions of deliberate practice are systematically undermined by default AI coding workflows. 25 years ago, I watched developers plateau because they spent years doing the same comfortable tasks in the same comfortable ways. AI has made it possible to plateau faster, earlier, and more invisibly than any tool I have seen in my entire career. But here is the critical question, and we are going to unpack this right now. If your skill is not actually growing, why do you feel like it is? The fluency illusion is the cognitive trap that makes AI-induced skill atrophy so dangerous and so hard to detect from the inside. Here is the mechanism in precise terms. Metacognition is your ability to accurately assess your own understanding and skill level. It is what lets you know the difference between I understand this concept and I have seen this concept. Accurate metacognition requires repeated cycles of prediction and verification. You predict you can solve a problem, you try without assistance, and the gap between prediction and performance is your calibration signal. AI destroys this calibration loop entirely. When AI writes your code and it works, your brain receives a success signal. Dopamine. Confirmation. I am good at this. But you never made a prediction about your own ability, and you never tested it independently. Over months, your self-model, your internal map of where your skill actually sits, drifts further and further from reality. This is clinically adjacent to what Dunning-Kruger describes, but with a crucial twist. Classic Dunning-Kruger is about low-skill individuals overestimating competence due to lack of knowledge. AI-induced fluency illusion hits mid to senior developers who have real skill, but whose self-assessment is now running on AI-augmented performance data rather than their own unassisted capability. I have watched developers with 5 to 8 years of experience completely freeze during system design interviews for roles they were genuinely qualified for, because they had lost the metacognitive thread of their own abilities. The next section is going to show you this is not anecdotal. The data piling up. I want to move from theory to signals you can actually observe in a team right now, because this is where the cognitive science stops being abstract and starts costing companies real money. Across teams that have moved to high AI dependency workflows over the past 18 to 24 months, several patterns are emerging with uncomfortable consistency. Onboarding ramp-up time for new developers is increasing, not decreasing, because new hires cannot read or reason about AI-generated code without running it, which means their base comprehension is lower. Code review comment quality is degrading. Reviewers are catching fewer logical errors and architecture issues because as they are reviewing AI-generated code with AI assistance, creating a blind spot loop. Production bug rates for edge cases and integration failures are climbing. AI excels at happy path code, but consistently underperforms on complex state interactions and distributed failure modes that require deep system understanding. And here is the one that hits hardest. Teams are now using AI to understand code that AI wrote. I have seen this in 3 separate enterprise teams. The original author cannot explain their own PR without querying the AI that generated it. That is not productivity. That is a knowledge debt bubble with no audit trail. The team velocity dashboard looks green. The architecture is quietly becoming unmaintainable. Wait until you see what developers are actually self-reporting about this, because the numbers are worse than most engineering managers realize. Let me close this chapter with something that hit the developer community like a cold shower. A thread on Geek News, the Korean developer community equivalent of Hacker News, went viral with thousands of responses when someone asked a simple question. Since using AI coding tools heavily, have you noticed any decline in your own abilities? The responses were not what the optimists expected. Developers with 3 to 10 years of experience were self-reporting an inability to whiteboard solutions they used to solve intuitively and quickly. Multiple responses described the specific experience of sitting down to debug a production issue without AI access, maybe an airplane, maybe a secure environment, and feeling a level of anxiety and disorientation they had not felt since their first year of coding. Several senior developers reported that their internal monologue during problem-solving had changed. Instead of reasoning through the problem, they were narrating prompts they would write for an AI. The problem-solving instinct was being replaced by prompt design instinct. This is not Luddism. These are experienced engineers who understand the value of tools, but they are noticing a shift in their cognitive relationship with code. And here is what you need to sit with before the next chapter. Every dependency wave I have lived through in 25 years, ID autocomplete, Stack Overflow copy-paste, and now AI generation has followed the same pattern. And the developers who came out stronger every time did something very specific. That specific pattern is exactly what we are going to examine in Chapter 3. Here's something most developers don't want to admit. This problem is new. I watched the first wave hit in the late 1990s. IntelliSense shipped with Visual Studio E7, and within 2 years I was seeing developers who literally could not write a method's signature without the IDE prompting them. I had a colleague, 5 years of experience, who froze at a whiteboard interview because there was no autocomplete. His fingers how to navigate drop-down menus. His brain had never fully internalized the syntax. We called it a quirk back then, I now recognize it as the first documented case of cognitive offloading at scale in software development. Tool wasn't filling a gap in knowledge. It was replacing the process that would have built that knowledge. And the developers who got hit hardest, the ones who onboarded directly into IntelliSense-enabled environments, they never had the struggle that builds the mental model. Sound familiar? Because what you're about to see next follows the exact same arc, just with a bigger tool and a bigger consequence. Then came Stack Overflow in 2008, and the pattern accelerated dramatically. I want to be precise about what actually happened, because people romanticize this era. Stack Overflow wasn't just a reference tool. For a significant portion of developers, it became the primary way they wrote production code. Find a question that looks like your problem. Copy the top voted answer. Adjust variable names. Ship it. I call this cargo cult programming, and I saw it everywhere between 2008-10. The dangerous part wasn't the copying, it was the context blindness that came with it. The answer on Stack Overflow was written for a specific scenario, with specific constraints, in a specific version of a library. The cargo cult programmer drops it into a completely different context and wonders why it breaks in production 6 months later. What they built was output velocity, without comprehension depth. They could ship features fast, but when requirements deviated even slightly from the copied template, they were completely lost. Here's the uncomfortable comparison. The Stack Overflow developer at least had to read the question and the answer. They had to do some pattern matching. With AI, even that minimal cognitive engagement is being removed. And that gap between what you produce and what you understand is exactly where skill atrophy lives. After 25 years of watching developers work, I've identified distinct stagnation profiles that keep appearing whenever a powerful new tool hits the market. The first one I call the promptimizer, and it's the most deceptive profile because on the surface this person looks like a star performer. They are extraordinarily skilled at extracting exactly what they need from an AI. Their prompts are precise, well-structured, and consistently produce usable output. Managers love them. They ship fast. But here's what I've observed in code reviews and architecture sessions. The prompt optimizer has a critical blind spot. They have optimized for output extraction, not for structural critique. When an AI generates an architecture decision, say recommending a microservices split versus a monolith refactor, the prompt optimizer evaluates it by asking the AI for pros and cons. They've lost the internal mechanism to challenge the framing of the solution itself. I've seen this developer accept AI-generated database schemas that were technically functional but would become catastrophic at scale, because validating the schema required domain knowledge they had stopped exercising. The dangerous illusion here is competence theater. They look capable because they produce results. But the moment the AI is wrong in a non-obvious way, there is no safety net. And AI is wrong in non-obvious ways more often than you want to believe. The second profile is one I have genuine sympathy for, because I understand the pressure that creates it. I call this developer the velocity addict. This person discovered that AI lets them ship features at a rate that was previously impossible, and that shipping rate became their identity and their protection. Here's how the pattern develops. Early on, they use AI to accelerate work they mostly understand. That feels great. Then a ticket comes in that's genuinely hard. Something that requires understanding how the event loop actually processes microtasks, or why a specific database index isn't being used by the query planner. The velocity addict reaches for AI, gets something that works, and moves on. They don't stop to understand why it works. And crucially, they feel like they made the right call because they shipped. But what they've done is made a withdrawal from a comprehension bank that they're not depositing back into. Every hard problem they skip is a compounding debt, not in their codebase, but in their head. I've reviewed systems built by velocity addicts, and there's a recognizable texture to them. The shallow parts are excellent, and the deep parts are completely opaque, even to the author. When those deep parts break, the velocity addict calls it a mysterious bug. It's not mysterious. It's the exact spot where understanding was never built. The next profile you're about to see is the one that surprises senior developers most, because it's probably them. The third profile is the one that I find most important to name clearly, because it affects experienced developers who think they're immune to this problem. I call this person the passive confirmer. This is typically a mid to senior developer, 3 to 10 years of experience, who has developed a specific response pattern to AI output. The AI generates code or an architectural suggestion. The developer reads it, thinks that looks about right, and approves it. Not because they've verified it. Not because they've run it mentally through edge cases. But because generating a meaningful counterargument requires effort, and confirming requires almost none. This is not laziness in the traditional sense. This is a rational response to cognitive load in a high-pressure environment. The consequence is profound. The senior developer is gradually surrendering the engineering judgment that took years to build. I've seen this in code review. A PR comes in with AI-generated error handling. The passive confirmer approves it because the structure looks familiar. They haven't asked, does this error handling preserve the right invariants for this specific domain? Does it handle the failure modes that are specific to this codebase's concurrency model? Those questions require active judgment. And if you stop exercising active judgment, you lose it. Exactly the way you lose muscle, you stop training. This is the pattern that should concern you most if you have seniority. Because what you're surrendering is the thing that made you senior in the first place. Now, I want to address the pushback I always get at this point. We said the same thing about IntelliSense. We said the same thing about Stack Overflow. Developers adapted and everything was fine. Here's why that argument fails this time, and I want to be technically precise about it. IntelliSense filled syntax gaps. It completed method names and parameter types. The cognitive work of actually reasoning about the algorithm, the data structure, the architectural pattern, that work still happened in the developer's head. Stack Overflow provided solutions to problems that were already formulated. You still had to define the problem. You still had to understand enough to write the search query. You still had to evaluate whether the answer applied to your context. That evaluation work still happened in the developer's head. AI does something categorically different. AI can now generate the problem formulation, the solution approach, the implementation, the tests, and the documentation. It can produce an entire reasoning chain. And when it does that, the cognitive work that would have built your skill doesn't happen anywhere. It doesn't happen in the AI. The AI doesn't learn from generating your code. And it doesn't happen in your head because you didn't do it. The skill-building work simply doesn't occur. That is not a difference of degree from IntelliSense and Stack Overflow. That is a difference of kind. And the implications for your career trajectory are severe enough that I want to lay them out precisely in the final scene of this chapter. Let me close this chapter with the career-level framing, because this is what I want you to carry into the next chapter. Skill atrophy from tool dependency is not symmetrical across career stages, and the asymmetry is ruthless. If you are in the first 3 years of your career and you are primarily vibe coding, you are not just failing to grow. You are setting a ceiling on the senior-level judgment you will ever be able to develop. Senior developers are not people who write more code. They are people who have internalized enough failure modes, enough architectural trade-offs, enough debugging pattern recognition, that they can make good decisions under ambiguity. That internalization struggle, it requires the productive friction that AI removes. You cannot shortcut it. If you are mid-career, 5 to 10 years in, the risk is different but equally serious. You have the title and the compensation of a senior developer. But if AI has been handling the hard parts for the past 2 years, there is now a gap between what your title implies you can do and what you can actually do under pressure. That gap is invisible until it isn't. A production incident, a technical interview, a system design review, these surface the gap with brutal efficiency. The good news, and there is genuinely good news, is that none of this is irreversible if you act now. In the next chapter, I'm going to give you 5 specific daily routines grounded in Erickson's deliberate practice research that let you keep using AI at full speed while actively building the depth that protects your career. These are not theoretical. I use them myself. Let's get into it. In the last chapter, we identified 3 recurring stagnation profiles across 25 years of tool-dependent developers. Now the real question is, what do you actually do about it? Not abstract advice. Concrete routines you can start this week. Routine 1 is called Design Before AI, and it is the single highest leverage habit I have seen separate growing developers from stagnating ones. Here is the rule. Before you open Copilot, before you type a single prompt into ChatGPT, you spend 10 to 15 minutes with nothing but a blank document or a whiteboard. You sketch the solution structure. You map the data flow. You name the edge cases. You are not writing code. You are forcing your brain to decompose the problem independently. Why does this matter neurologically? Because the moment you see AI-generated output, your brain shifts from generative mode to evaluative mode. Evaluation is cognitively cheaper, and your brain will take that shortcut every time. The design-first routine closes that escape hatch. I have personally watched senior developers who skipped this step for 2 years and could no longer architect a 3-service system without an AI scaffold. Do not become that person. But designing first is only half the battle, and what happens after the AI responds is where most developers completely fall apart. Once you have your AI-generated code in front of you, most developers do one of 2 things. They accept it immediately, or they skim it for obvious syntax errors. Both behaviors are career poison. Routine 2 is mandatory self-review of all AI output, and I want you to treat it as seriously as you would treat a pull request from a junior developer on your team. Because that is exactly what AI-generated code is. It is output from a very fast, very confident junior who has no understanding of your specific context, your security requirements, or your team's architectural decisions. Here is the 4-category review checklist I use and teach. First, correctness. Does this code actually do what I asked? Or does it do something subtly different? AI models are optimistic. They generate plausible-looking code, not verified code. Second, security. Are there injection vulnerabilities, exposed secrets, missing input validation? Third, performance. Are there N+1 query patterns, unnecessary memory allocations, blocking calls in async contexts? Fourth, architectural fit. Does this code respect the layer boundaries, naming conventions, and dependency rules my team has established? Skipping this checklist is not saving time, it is borrowing time from your future self. And that debt comes due in production at the worst possible moment. Now let me show you what the difference actually looks like in practice, because there is a massive gap between what developers think is a code review and what a real code review is. I call the first pattern rubber stamp review. The developer looks at the AI output, sees that it compiles, spots no obvious typos, and clicks accept. The mental process takes about 8 seconds. This is not a review, it is a formality that creates false confidence. Here is what a structural review looks like instead. When I review an AI-generated function, I ask specific interrogation questions. Does this function have a single responsibility, or is it quietly doing 3 things? What happens when this argument is null? Why did the AI choose this abstraction? Is there a simpler one that fits our codebase better? If this function fails, will the error message tell me anything useful? These are not hard questions, but they require you to engage cognitively with the code rather than passively receiving it. The cruel irony is that rubber stamp review feels efficient. You merge fast, you ship fast. 2 weeks later, you are in a production incident at 2 a.m. debugging code you do not understand, written by a tool you trusted, without verification. The time you saved in review is now multiplying against you in the incident timeline. Next, we go underground, literally turning off the AI, and I will show you why that is the most valuable thing you can do for your career right now. Anders Ericsson spent decades studying what separates elite performers from competent ones. His conclusion was not talent, it was deliberate practice. Working at the edge of your current ability, with full cognitive engagement, and with feedback, AI tools, by default, eliminate all 3 of those conditions. So routine 3 is about deliberately restoring them. I call it the no AI session, and here is the exact implementation. Block 2 to 3 hours per week. I personally use Tuesday and Thursday mornings before Slack opens, and disable all AI assistants, not just Copilot. Close the ChatGPT tab. Turn off the AI-powered search. Then pick a problem that is genuinely at your learning edge. Not a trivial QROD endpoint. Not a feature you have built 10 times before. Pick something that makes you slightly uncomfortable. A data structure you have been meaning to understand. A concurrency pattern you usually reach for AI to handle. An unfamiliar library you keep avoiding. The discomfort you feel is not inefficiency. That discomfort is the neurological signal of active learning, what Bjork calls desirable difficulty. Your brain is being forced to retrieve, to struggle, to build durable pathways. I have mentored developers who added 2 no AI sessions per week and reported that, within 6 weeks, they felt fundamentally different, not just in confidence, but in the speed of their independent problem solving. But here is the uncomfortable truth. No AI sessions alone are not enough if you are still letting comprehension gaps slide past you during regular AI-assisted work. Richard Feynman had a simple test for whether he truly understood something. Could he explain it from first principles to someone with no background? If he could not, he did not actually understand it. He had memorized the surface. Routine 4 applies exactly this test to every block of AI-generated code you accept. Here is the rule. After you accept any AI-generated code block, you have 3 minutes to explain it line by line, out loud or in writing, as if you are teaching it to a junior developer. Not summarizing, not paraphrasing, line, line, line. What does this variable hold at this point? Why is this conditional checking that specification? What side effects does this function produce? Why is data structure chosen over an alternative? Here is what I have observed in code review sessions with teams using AI heavily. Developers can describe what the code does at a high level. It handles authentication. But they cannot answer specific questions about why any particular line exists. That gap between high-level description and line-level comprehension is exactly where production bugs hide. The 3-minute explainability test costs almost nothing when understanding is genuine. But when understanding is shallow, it immediately surfaces the gap. And that is not a failure. That is the most valuable data point in your learning process. So what happens when the explainability test fails? Most developers do one of 2 wrong things. They either shrug and move on. It works, that's enough, or feel ashamed and avoid the topic. Neither response builds skill. Here is the feedback loop I have refined over 2 decades of mentoring. Step 1. When you hit a line you cannot explain, stop immediately and name the gap with precision. Not "I do not understand this code." Specifically, "I do not understand why this closure captures the outer variable rather than receiving it as a parameter." Precision is everything. A vague gap stays vague. Step 2. Find the minimum resource to close that specific gap. Not a tutorial. Not a YouTube series. A targeted search, the official specification, or a senior colleague who can answer in 5 minutes. Step 3. Before you move on, write one example yourself, from scratch, without AI, that demonstrates the concept you just learned. This is the encoding step that most developers skip, and it is the difference between short-term recognition and long-term retention. Step 4. Rerun the explainability test on the original code. If you can now explain it, you have converted an AI-generated comprehension gap into a permanent skill addition. You have literally turned AI's output into your own knowledge. Every routine we have covered today costs real time. So in the next section, I am going to show you exactly how to integrate all 5 into a weekly schedule that takes under 4 hours total. The 5th routine is the one that ties all the others together, and it is the most sophisticated one to implement. I call it progressive difficulty calibration, and it is directly derived from Gatsky's zone of proximal development, the idea that real learning happens in the narrow band just beyond your current independent ability. The problem with most AI usage is that it collapses that zone entirely. Everything becomes equally easy. Here is the tiered framework. Tier 1, known patterns. If you are writing boilerplate you have implemented dozens of times, standard SROD, familiar middleware patterns, routine configuration, full AI assistance is appropriate. Your brain gains nothing from struggling here. Use the tool and move on. Tier 2, adjacent skills. If the task is one step beyond your comfortable familiarity, a library you have used once, a pattern you understand conceptually, but have not implemented it in production, use AI for prompting and exploration only. Generate the suggestions, but do not accept the output directly. Read it, close it, and write your own implementation. The AI is a reference, not a co-author. Tier 3, new domains. If you are genuinely in unfamiliar territory, a new language, an architectural pattern you have never implemented, an algorithm outside your background, use zero AI assistance for the initial learning phase. Only introduce AI after you have built a working mental model through independent struggle. The calibration question to ask yourself every morning is simple. For this task today, which tier applies? That single question, asked consistently, keeps you permanently at the learning edge, regardless of how heavily you use AI overall. Let me bring everything together into a concrete weekly picture, because I know what you are thinking. This all sounds good, but I already have a full-time job, a backlog, and a sprint review on Friday. I have heard that every time I have taught these routines. So here is the honest math. Routine 1, design before AI, adds 10 to 15 minutes you were already doing. Call it 45 minutes per week amortized. Routine 2, mandatory AI output review, replaces the rubber stamp you were doing anyway. Real cost is about 30 minutes per week of extra cognitive engagement. Routine 3, no AI sessions, is 2 blocks of 90 minutes each, 3 hours per week, scheduled in advance. Routine 4, explainability tests, is 3 minutes per accepted AI block, call it 20 minutes per week if you are using AI heavily. Routine 5, difficulty calibration, is the 30-second question every morning, negligible time cost, significant behavioral impact. Total, under 4 hours per week. 4 hours per week is the price of staying competitive in an industry where AI is accelerating the gap between developers who can think independently and those who cannot. And here is the return on that investment. Each of the 5 routines directly counters one of the 3 stagnation profiles we identified in the previous chapter. Design for AI counters the shallow acceptor. Structural review and explainability tests counter the confident incompetent. No AI sessions and difficulty calibration counter the skill atrophier. But knowing these routines in a lecture room and applying them when production pressure is real are 2 very different things. In the next chapter, I am going to take you to production war stories, where AI dependency broke at the worst possible moment. Because theory is one thing and 2 a.m. is another. Let me tell you about a production outage I witnessed firsthand. 3 a.m. Payment service down, revenue bleeding by the minute. The culprit. A threading implementation that an AI generated that passed every single unit test, every integration test, every code review. It only broke under real production load with 400 concurrent users. Here is the actual code on screen. See this shared counter being incremented across threads? The AI produced a solution that looked textbook correct. It even added a comment saying thread-safe implementation. But it used a non-atom read modify write sequence without proper synchronization. The senior engineer on call The one who had approved this PR stared at it for 40 minutes without identifying the root cause. Why? Because he had not written raw threading logic by hand in 18 months. His mental model for concurrency had gone cold. He knew the vocabulary, but the intuition, the part that makes you smell a race condition, that part had atrophied. AI wrote the code, AI passed the tests. And when production broke the rules AI never tested for, there was no human in the room who could read the battlefield. And here is what makes this truly dangerous. This was not a junior engineer. This was a 7-year veteran. But wait, the concurrency story is actually the least surprising of the three. The next one will make you rethink your entire onboarding process. War Story 2. A new hire joins the team, strong bootcamp background, solid portfolio, ship real features at their previous job using AI tools throughout. Smart person, genuinely motivated. The onboarding estimate was 4 weeks, standard for this team. At week 4, they had merged exactly one PR, not because they were not working hard, because they were working in a way that did not function without AI assistance. The legacy codebase, 8 years old, mixed paradigms, no AI indexing support. Something that modern AI-assisted development had never trained them to do. Reading unfamiliar code, building a mental map of execution flow without autocomplete, tracing a bug through abstraction layers using nothing but their own reasoning. They had never had to do this before. Every job, every project, every learning exercise had AI filling the gaps. When you remove the scaffold entirely, what is left? In this case, not enough. Their ramp-up extended to 14 weeks. The team lead told me it was like every word in the dictionary, but had never had to write a sentence without autocomplete. The cognitive skill of reading and reasoning through unfamiliar code, what researchers call code comprehension, is a separate muscle from code generation. And 14 weeks of lost productivity is the price of letting that muscle go unexercised. But here is the thing, this story at least had a recoverable outcome. The third story could have ended with a supply chain compromise. Let me show you exactly what happened. War Story 3. This one is short. The blast radius could have been catastrophic. A developer asks an AI assistant to recommend a data validation library for a Node.js project. The AI confidently suggests validate schema utils, plausible name, fits the naming conventions of the ecosystem, even provides a sample usage snippet that looks legitimate. The developer does npm install without checking the npm registry page, without checking the GitHub repository, without checking the weekly downloads, without checking the maintainer history. Why not? Because over the previous 8 months, they had conditioned themselves to accept AI package recommendations as pre-vetted. In their experience, AI suggestions had always worked. The habit of independent package research had been replaced by AI delegation. What they installed was a typo-squatting package, a malicious clone sitting on npm waiting for exactly this kind of auto-accepted install. It had an exfiltration payload in the post-install script. Security caught it in the pipeline, fortunately. But the key question is not how did this happen, it is why did it feel normal? Because had systematically untrained their verification instinct. Now, all three of these stories feel different on the surface. Different failure modes, different teams, different experience levels. But when I map them side by side, the same root cause appears every single time. And understanding that root cause is how you prevent all three simultaneously. 3 incidents, 3 different failure modes, 3 different experience levels, and yet when you put them on the same map, they share exactly one root cause, and it is not AI hallucination. Let me say that again clearly, because the industry keeps blaming the tool. It is not the AI that failed. The AI did what AI does. It generated plausible output based on pattern matching. The failure was in the humans who lost the capacity to evaluate that output independently. In the concurrency story, the developer could not diagnose the race condition because the mental model for threading had gone cold. In the onboarding story, the developer could not read unfamiliar code because the comprehension muscle had never been built without AI assistance. In the supply chain story, the developer did not verify the package because verification habit had been systematically replaced by AI delegation. The pattern is identical across all three. A specific technical judgment capacity had atrophied, and AI output flowed into that gap unchecked. This is what I call judgment miscalibration, not the inability to use AI, but the inability to apply independent skepticism to AI output, because the mental models needed to evaluate it have weakened. And here is the part that should genuinely concern you. Judgment miscalibration is invisible until it fails catastrophically. You feel productive right up until the moment production burns. So the question becomes, how do you know which of your judgment capacities are currently at risk? The answer is in the calibration model we are about to build. So how do you actually operationalize this? Not with vague advice like be more skeptical. That is useless under pressure at 3 a.m. What you need is a calibrated trust model, a concrete map of which categories of AI output require mandatory independent verification, versus which categories are safe to accept with light review. The model is built on two axes, risk and novelty. High risk, high novelty output, like a new concurrency implementation, a new dependency, or security adjacent code, always requires mandatory independent verification. You must be able to evaluate this output on its own merits without relying on the AI to have gotten it right. Medium risk, familiar patterns, like a standard eroding implementation framework you know deeply. Light review is appropriate, but you should still be able to explain every line if asked. Low risk, repetitive boilerplate, tests for known patterns, documentation formatting, config file structure, acceptance with spot check is reasonable. The critical habit is not to apply maximum skepticism to everything. That defeats the productivity benefit entirely. The critical habit is knowing which bucket each piece of AI output falls into before you accept it. And that knowing requires you to have the independent mental model in the first place. Which brings us full circle. The 5 routines from the previous chapter are not optional extras. They are the maintenance schedule that keeps your judgment calibration accurate. Now in the next chapter, we shift perspective entirely. Because if you are a team lead or engineering manager, the problem is not just your own judgment. It is designing an environment where your entire team does not drift into the same traps simultaneously. That is a systems problem, and it requires a systems solution. Let me be brutally honest with you right now. If you are a team leader still measuring developer performance by tickets closed per sprint, PRs merged per week, or lines of code shipped, your evaluation framework is broken. And it was already imperfect before AI. But now, AI has turned these metrics into pure noise. I have seen developers on my teams who looked like rock stars on the velocity dashboard. 30 tickets closed in a sprint, 20 PRs merged, thousands of lines shipped, and then the system goes down at 2 a.m., and not a single one of them can explain why the caching layer was designed the way it was. Because they never designed it, Copilot did, they accepted the suggestion and they moved on. Here is the dangerous illusion. AI inflates output without inflating understanding. Your high-velocity developer might actually be your highest-risk developer. The person closing 10 tickets thoughtfully, asking hard questions, rejecting AI suggestions that do not fit the architecture, that person is building real leverage. But your current metrics are probably marking them as underperforming. So ask yourself right now, are you measuring productivity, or are you measuring AI usage? Because those are two completely different things, and the difference will define your team's ceiling. Coming up next, I will show you exactly what to measure instead. So what do you actually measure instead? After 2 years of experimenting with this on my own teams, here is what I have landed on, the explainability test. It is simple. And it surfaces the truth in under 20 minutes. Here is how it works. You sit down with a developer, no AI tools, no Stack Overflow, documentation open, and you point at a piece of code they recently shipped. Then you ask 3 questions. 1. Walk me through the architectural decision here. 2. What are the top 3 ways this could fail in production? 3. If you had to implement this differently, what would you change and why? If they answer all 3 fluently, they own that code. If they stammer, if they say the AI suggested it, and it seemed right, you have found your gap. Now, I am not saying fire anyone. I am saying you have just identified where your team needs deliberate investment. For hiring and onboarding, I now use constrained explanation interviews. Candidates get a piece of legacy code, 30 minutes no AI, and they must explain it and propose one improvement. The goal is not perfect answers. It is watching how they think under cognitive friction. Because that friction is exactly what vibe coding removes. And a developer who cannot operate without AI scaffolding is a liability you are hiring into your critical path. The next section reveals how to build team culture that prevents this problem from ever taking root. Evaluation tells you where you are. Practice determines you go. And here is the uncomfortable truth about team culture in the AI era. If you do not deliberately design friction into your team's workflow, the natural gravity of convenience will pull everyone toward maximum AI dependency. So let me give you 3 concrete practices I have implemented and what happened when I did. First, AI off problem-solving sessions. Once every 2 weeks, the team takes a real bug or a small feature, nothing mission critical, and solves it with AI tools completely off. No Copilot, no ChatGPT, no AI-assisted search. Just the developer and the documentation. The first 2 sessions are painful. People are slower than they expected. And then that discomfort. That is exactly Bjork's desirable difficulty doing its job. By session 5, I watched a junior developer who had been on the team for 8 months independently debug a race condition, something they had never done without AI before. Second, code archaeology. Pick a module that was written 2 years ago. No AI context. Developers must read it, understand it, and present it to the team. This rebuilds the skill of reading code, which AI has been quietly atrophying. Third, structured peer reviews. Not just reviewing what the AI generated, but asking out loud, why did we accept this suggestion? What assumptions is it making? Could it fail here? These 3 practices cost you maybe 3 hours per 2-week sprint. The return is a team that owns its code base instead of renting an AI. But practices alone are not enough. Leaders need a framework. That is what comes next. Now let me give you something you can bring to your next leadership meeting. I call it the 3-layer AI governance framework. Think of it like a stack, and just like any good architecture, each layer has a distinct responsibility, and they must all work together. The bottom layer is tool policy. This is where you define the rules of engagement, which AI tools are approved, what data they can touch, and critically, where AI assistance is restricted, not because AI is bad, but because some contexts require unassisted competence. Production incident response, security-sensitive modules, architectural design sessions. Document this. Enforce it. The middle layer is measurement. This is where you put everything we discussed in Section 1. The explainability test, comprehension assessments, AI suggestion audit trails in PR reviews. Your measurement layer must surface skill growth, not just output volume. If your metrics cannot distinguish a developer who owns their code from one who pastes AI output, your measurement layer is broken. The top layer is culture. This is the hardest one. Culture is what your team does when no one is watching. Does the developer reach for AI the moment they feel friction? Or do they sit with the discomfort for 15 minutes first? Culture is set by what leaders model, what behaviors get rewarded, and what stories get told. The developer who debugged something hard without AI and shared how, that story needs to be celebrated louder than the developer who shipped the most tickets. 3 layers. Tool policy, measurement, culture. Get all 3 aligned, and you have a team that extracts AI's productivity gains without surrendering its intellectual depth. And that is how you build a team that is still competitive 5 years from now, not just next quarter. We have covered a lot of ground in this lecture, from the cognitive science of why coding creates the illusion of competence, to production failures that expose the gap, to everything I just walked you through for team leaders. So let me close with something concrete. 3 actions. This week, not someday. Action 1. Start routine 3 this week. Pick one problem, one real problem from your actual backlog, and solve it with AIOs off. Time box it to 90 minutes. Notice what you struggle with. That struggle is your learning signal. That is where your real skill gap lies. Action 2. Apply the explainability test to the very next AI-generated PR that comes across your desk. Your own, or a teammate's. Point at one block of AI-generated code and ask, can I explain why this is the right solution, what it assumes, and how it could fail? If the answer is no, do not merge it until you can. Action 3. Share the stagnation profile framework, the one from Chapter 2, with one teammate this week. Just one. Not a lecture. A conversation. Hey, I watched this thing about AI dependency patterns. Made me think about how I use Copilot. Want to talk about it? That conversation alone plants a seed that changes how someone practices. Now, the core message of this entire is this. AI does not make you a better developer. It makes you a faster one. And those are not the same thing. What makes you better is what you do with the friction that AI removes. If you let AI take away all the, you are not growing. You are renting competence from a server farm. But if you use AI deliberately, strategically, with full awareness of what you are offloading and why, then AI becomes the most powerful lever in your career. 25 years of watching developers grow and stagnate has taught me one thing. The developers who thrive in every era of tooling change are the ones who never stop owning their thinking. That is the developer you choose to be. Starting this week.